All right. Good morning, everybody. Week number 3 starts today. Um, it's I'm not sure how much of this you guys have seen before. I kind of enjoy this stuff this week. What we're going to be doing this week, in a nutshell, is we're going to be solving for missing sides. We're not going to use sine, cosine. I shouldn't say that. We are going to be using sine, cosine, and tangent on a couple, but not many. We're going to use what is called special triangles. Have you guys heard of special triangles before? All right. So if you know special triangles, you're going to just whip right through this week's assessment, okay? If you don't understand special triangles, you're going to be looking at it like, what the heck is he asking for? Okay, so let's review special triangles. There are two different types of special triangles, okay? 30, 60, 90 and a 45, 45, 90. And let me just review, and if you didn't watch my awesome lesson tutorial, I'll just go through it really quick. If you remember an isosceles triangle, an isosceles triangle says that all sides are the same, right? Oh no, I'm sorry, an equilateral triangle. That's where I'm going. Okay. Equilateral triangle. Equilateral triangle, all sides are the same. All angles are the same, correct? On an equilateral triangle, this would be 60. This would be 60. This would be 60. Okay? Now, if you cut that triangle directly in half, you get two triangles, right? And what are those triangles? They are what we call 30, 60, 90. 30, 60, 90. How did I get that 30 degrees right there? Because I cut that 60 degrees in half, right? Exactly. So now, if we had an equilateral triangle, if this side was 10, this side would have been 10, this side would have been 10. So if this side is 10, what's this side right here, down at the bottom? It would be half of it, right? Because we just cut it in half. It'd be 5. And you could use Pythagorean theorem to get this side, but I will tell you that it's always the short side times the square root of 3. So it's 5 to the square root of 3. So if I gave you this triangle right here, and I said that this was 30, 60, 90. Oh, that's 90 right there. And I said that this side was, let's say, 20. What would this side be? What would the short side be? 10. What would the long leg be? 10 to the square root of 3. Right. Awesome. That's how easy it is. Now, let me give you a harder one. Let me give you one that 30, 60, 90. Let's say that this side is, let's say it's 9. They gave you the long leg. How do you find the short leg? Tricky, Mr. Shanglin. Divide by the square root of 3. That's exactly right. Because we took the short side and multiplied by the square root of 3 to go to the if I had the long leg and I want to go to the short leg, I divide by the square root of 3. Can you leave that? Can you leave a square root of 3 in the denominator? No. So we're going to multiply top and bottom by the square root of 3. So that gives me 9 to the square root of 3 over 3. So that really is 3 square root of 3. Woo! So the short side is 3 square root of 3. What's the hypotenuse? Because the hypotenuse is just double that, right? What's double 3 square root of 3? What is? So if I multiply this by 2, that gives me 6 square root of 3. Boom. Awesome. Love it. And that, for those of you that are good with special triangles, let me see if I have any. I just want to see if I have. Oh, I do. Oh, okay. So I don't know why I'm writing really small. Okay. So let's go to the 30, 60, 90s first. Okay. So here's a 30, 60, 90. If this is x, this is 2x, this is x times the square root of 3. So let's try some examples. if this is the problem that I gave you, okay, so this has to be a 30, 60, 90-degree triangle, right? That's too many. Yeah, but if you understand what you're doing, it's so easy. That's the trick. When you understand these, it's like, okay, so here the hypotenuse is 12. So the short side is 6. That means this is 6 square root of 3. Boom. Now, is there a lot of work to show there? Is there a lot of work? Not really. This week, there will not be a lot of work to show, because if you know what you're doing, it's like boom, boom, boom. Okay, so here, I have 72. What is side B? 36. What is A? 36 square root of 3. Right. Short side times square root of 3. Okay, in this problem, I'm given the short side in these two. I'm given the short side. So what's the hypotenuse? What would x be? 10, right? Just double the hypotenuse. What's the long leg? Short side times the square root of 3. 5 square root of 3. Boom. Uh-oh, this one looks tough. I got 5 to the square root of, or 13 square root of 3 in here. What's the hypotenuse? No, that is not the hypotenuse. This is the hypotenuse. Remember, the hypotenuse is double the short side. So 13 square root of 3 times 2 is equal to 26 square root of 3. What is y? What is y? What do we do from the short side to the long leg? We times the square root of 3, right? Oh, Allison, I would not give you credit for that. No decimals this week. No way, no way, no way. 13 square root of 3 times the square root of 3, right? Don't we just multiply the square root of 3? So I have 13 square root of 3 times the square root of 3. What is the square root of 3 times the square root of 3? Isn't that just 3? So isn't this just 13 times 3, which is 39? Yeah. Some of you are going to go through this week's assessment and it's going to be boom, 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 done. That's all there is. Some of you are going to look at it and it's like, oh man, okay, I got the short side, I got to multiply by 2 to get to the hypotenuse, I have to multiply by the square root of 3. That's fine. But I love these things. All right, now, this one's a little bit harder. This time I give you the long leg. What's a short leg? Remember, to go from short leg to long leg, we multiply by the square root of 3. So to go backwards, we have to divide by the square root of 3. What is 29, the square root of 3, divided by the square root of 3? It's 29. It is indeed. What's the hypotenuse? It is that easy. Hypotenuse is 58. That's exactly right. It's a short leg times 2. This is probably the hardest type of problem that I can give you. Okay. 36. What's a short leg? Remember, the rule doesn't change. I still have to divide by the square root of 3, right? So it's 36 divided by the square root of 3. Yeah, Mr. Shanklin's not going to let me leave a square root of 3 in the denominator. So I have to multiply top and bottom by the square root of 3. So I'm left with 36 square root of 3 over 3. Well, 36 and 3 comes down. What the heck is going on with my marker here? Oh, no. No. Okay, so I'm just going to say it. Is it, what, 12 square root of 3? No, marker has too much ink. It's just going nuts on me. Oh, my goodness. What is going on here? Huh. That is going to make it for a really hard day to write if it just, holy cow. I am sorry, guys. Something is really messed up with my writing tablet. Okay, so I'm just gonna leave it. All right, so that's a 30, 60, 90 degree triangle. Oh, now my mouse is doing the same thing too. All right, I'm unplugging it, seeing if, oh boy. Okay, so now we're going to go back to the 45, 45, 90. Okay, 45, 45, 90-degree triangle. What does that come off of? It comes off of a square. If you think about it, a square, no, my board is not working at all. Okay, here we go. So if I have a square, all angles are 90, right? And all sides are the same. So let's say that this side is 10, 10, 10, 10. Divide it in half. That gives us what is called a 45, 45, 90. That's a special triangle. 45, 45, 90. So this side's 10, this side's 10. If I use Pythagorean theorem, this side will always become the one side times the square root of 2. Always. So that's how we come up with the side. So let's say I gave you this as 20. I said, oh, they gave me the hypotenuse. What's the side? Well, to go from the side to the hypotenuse, we multiply by the square root of 2. So what do you think we have to do to get backwards, to go backwards? If I know the hypotenuse, I'm going to have to divide by the square root of 2. And that's where some of you will mess up, because it's going to be 20 over the square root of 2, but I won't let you leave a square root of 2 in the denominator. That's a no-no. So I'm going to multiply top and bottom by square root of 2. So that gives me 20 square root of 2 over 2, which is 10 square root of 2. Okay? Does that make sense? I went through it really quick. I want to make sure we have enough time to do our practice. All right, so here's a couple examples. Again, you should be able to do these no problem. If this is 5, this is 5, this is 5 square root of 2. If this is 8 square root of 2, this is 8 square root of 2, this is 16. Mr. Shannon, where did you get 16 from? Can somebody explain where we got 16 from? 8 times 2. Why 8 times 2? Because I take the short side, or I take the side times the square root of 2. Well, 8 square root of 2 times the square root of 2 really is 8 times 2, which is 16. Awesome stuff. Love it. All right, now, what if I gave you the hypotenuse? Guess what? We just divide by the square root of 2. So what is 15 square root of 2 divided by the square root of 2? Just 15, 15. That's exactly right. Boom. What if it's 2? Oh no, what's this side? Well, you have to divide by the square root of 2. Well, can't leave that square root of 2 in the denominator. So this is going to be 2 square root of 2 over 2. That's going to be square root of 2. Square root of 2. The assessment is set up exactly the same way. Problem 1, problem 2, it just boom, 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 boom. You're done. Now, those are special triangles. We also have using sine, cosine, and tangent to find a missing side. Okay, so in order to find a missing side using sine, cosine, and tangent, so let's say they ask me to find this side right here. Okay, so the first thing I do is I look at the angle that I have, and I ask myself, which trig function? Allison, I can't, because we will never get our practice problems in. You can. This is all on the lesson tutorial. I'm just going through a real quick review of everything that I went through on the lesson tutorial. But you can always go back and watch the lesson tutorial. That's perfectly fine. I'm just trying to get through. I'm just trying a real quick review of that. So now, if I have a triangle like this, I can use sine, cosine, or tangent. Well, opposite, hypotenuse. That's the sine function. So that would be the sine of 34 degrees is equal to opposite over hypotenuse. That's a 25. Well, what is the sine of 34? I don't know what the sine of 34 is. It looks like it's 0.559. So this would be 0.559 is equal to x over 25. Multiply by 25, you get the missing side. Again, most of this stuff you should have gone through in geometry, correct? Sine, cosine, tangent, all that kind of stuff. All that stuff you should have had in geometry. Now, the only thing you probably did not have in geometry, I don't want to go through those, is the sine graph and the cosine graph. You guys need to memorize this, okay? Especially for those of you that are going to go into higher math. If you can memorize this, it's going to be so easy for you. Sine goes up to 1, and this is going to help next week too, because next week we're going to graph sine and cosine. Sine goes down to -1, so it goes up to 1, goes down to -1. Pi over 2, it starts at 0, goes to pi over 2, goes to pi, goes to 3 pi over 2, goes back up to pi, and then it's called the periodic function, so it keeps going, it repeats itself over and over and over again. So if you look at this sine graph, okay, if you look at this sine graph, what is the sine of 0 degrees? No, look right here, 0 degrees. It's equal to 0. What is the sine of 90 degrees? Well, this is 90 degrees, this is 180 degrees, this is 270, this is 360. Okay, that's converting from degrees to radians and all that. So the sine of 90 degrees is 1. What is the sine of 270 degrees? This is 270 right here. -1, right? So being able to memorize this graph, you know what 4 or 5 trig values are. You know what 0 is, 90 degrees, 180 degrees, 270, 360. You also know this, if you put a line right here, 180 degrees, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Where is the sine function positive? Which two quadrants is the sine function positive? 1 and 2. Where is the sine function negative? So if I asked you, if I said, what is the sine? No, I don't. Let's see here. So 80 plus 45, 120, 225. If I asked you what the sine function of 225 degrees is, okay, first thing I would do is I'd look at this and I'd say, okay, 225 degrees. That's way over here, isn't it? What is my reference angle? Okay, what is the reference angle? Isn't that 45 degrees? Ah, it's 45 degrees. Ah, so now I go back to my 45 degree triangle. And remember, if this was square root of 2, this would be 2. Is that square root of 2 times square root of 2? So that would be 2. Okay. Now, so what is sine? Sine is opposite over hypotenuse. So the sine of 225 is the square root of 2 over 2. However, it's negative. It's in the third quadrant. Negative square root of 2 over 2. If you knew this, when you get into higher math, now you can use what's called the unit circle, which has all this stuff on it. I used to have my kids memorize the unit circle, and then after about 10 years, I started teaching them how to create the unit circle. And the only thing you need to know on how to create the unit circle is you need the special triangles and the sine graph and the cosine graph. You could have used anything. You could have used 1 here. You could use any number in here that you want. It really doesn't matter. But remember, if you use 3 here, what would this be? Well, you'd have to divide by the square root of 2, right? So that would be, that'd be the 3 square root of 2 over 2. You could use any number you want. It's just, we normally just use the, I guess we could have used 1. That would have worked too, and this would have been the square root of 2. So the sine would have been 1 over the square root of 2, right? Which if you multiply by the square root of 2 over square root of 2, you end up with the exact same thing. So it doesn't matter which numbers you use there. If you reduce it down, you'll end up with the same thing regardless. Okay, and then the last thing I have to talk about is the cosine graph. Now, the cosine graph is, and this is going to be a whole, if you remember this for next week, it's going to help you out immensely, because next week we're going to graph sine and cosine. So the cosine graph starts up here. So this is the cosine graph. It starts here, goes down, comes back up. So what is the cosine of 0 degrees? Just by looking at the cosine graph. 1. What is the cosine of 180 degrees? No, it has to be between -1 and 1. 180 degrees is pi, so it's -1, right? It's -1. So those are two graphs that you need to know. All right, we need to get into our practice this week, or else we're never going to get done. I apologize. I love this stuff. It's so cool. And once you understand it, and most of you aren't going to understand it right away, it's one of those things that's like, wow, that is so cool that when you can do that. Is there a tangent? There's a tangent graph, a cotangent, a cosecant, all those graphs. We are only going to deal with sine and cosine next week. Okay? We're not going to get into the tangent and the cotangent and all that. Sine and cosine, that's it. That's what we're going to work on next week. And for those of you that really remember a lot about graphing functions, guess what next week we're going to do? I'm going to give you a graph. Here's the sine graph, right? What do you think this would look like? And if you can tell me this, I'm going to just blow it up and say, oh. What do you think is going to happen to that graph? Yes, it's going to shift up 2 units. It doesn't matter if it's quadratic, if it's exponential. That 2 on the backside is just going to move it up 2 units. So this graph would, instead of being here, it would go up here and it would look like this. That's half the battle next week. Once you know the parent function, what do all the numbers, what do you think this graph is going to look like? Sine of x plus pi. Okay, so now it's inside the parentheses. What does that do? Shifts it to the left pi units. Boom. That is what we're going to do next week. We're going to be shifting graphs around. It's awesome stuff. It really is. I love it. I love this stuff, but this is stuff that kids really struggle with, I will say. I'm not gonna lie. Okay, so I gave you guys the Desmos presentation, right? So let's get going on that, because we need to, you guys would be mad at me if I don't finish up the practice problems, right? All right, so let's get into, let's see here. Oh boy, I really messed up here. I want to go here. Oh, I'm really flustered right now. I don't know what I'm doing. I want to share. That's what I want to do. I want to share my screen. Yes. Okay, so Algebra 2. All right, so here's the first problem. Hopefully you guys can see the same thing I'm seeing. All right. So the first problem, it says, Wayne used the diagram to compute the distance from Ferris to Dunlop to Butte. How much shorter is the distance directly from Ferris to Butte than the distance Wayne found? Now, this is not a special triangle. It's not a special triangle. We're just going to have to use Pythagorean theorem on this thing. Yeah. We have to use Pythagorean theorem to figure this out. So in this problem, I would do 15 squared plus 20 squared is equal to, and we'll call this C here, is equal to C squared. Thank goodness I have a calculator at hand. So 15 squared is a 225. 20 squared should be 400 is equal to C squared. So if I add that together, I get 625 is equal to C squared. So 625, the square root of 625, right? The square root of 625, which is 25. So how much shorter? Remember, we don't want to use 25 as our answer, right? It says, how much shorter is it? So if I go straight from Ferris to Butte, it's 25, so it's 10. Okay, so 10 is our answer for problem number 1. Now, That doesn't have anything to do with what we're dealing with this week, right? We're dealing with special triangles and sine and cosine. All right, so this one is a little bit more along what you're going to be doing this week. Okay, so this problem, you should be able to look at that and tell me what the answer is. You should not have to do any work on it, right? 6. Why the question mark? That is what I would ask. Why put a question mark in there? You're not confident. You should be. Because remember, to go from, this is a 45, 45, 90 degree triangle. To go from the side to the hypotenuse, we multiply by the square root of 2. Square root of 2 times square root of 2 is 2. So this whole problem comes down to 3 times 2, which is 6. That's it. Special triangles, when you get good at special triangles, and for those of you that are 11th graders that are going to take the ACT test, I guarantee you there will be special triangles on the ACT. No question about it. Always is every year. Okay, every year there is special triangles on the ACT test. Okay, so you'll see them if you're taking the ACT test this year. All right, question number 3. It says, in triangle ABC, angle A is a right angle and angle B is 45 degrees. Oh, awesome. As soon as they tell me that this is 45 degrees, do I know the other angle is 45 degrees? I absolutely do, because all triangles add up to 180 degrees. So I know that this is a special triangle. It's 45, 45, 90. So they gave me one side. If your answer is not an integer, leave it in simplest radical form. It wants me to find BC. 11 squared root of 2. Boom. Done. Isn't that awesome? When you understand the rules to special triangles, there's really no work. Now, am I going to put, in order to get credit on this assessment this week, you need to show your work? No. That is not going to be one of my comments this week. Because most of you are going to be able to do the assessment this week in your head. You're going to be able to look at it and say, oh, that's 11 squared root of 2. Oh, that's this. Oh, that's that. I'm not going to be looking for a lot of work this week. Okay? But if you want to show your work, go for it. I don't care if you want to show your work, but as I said, there really isn't a lot of work to show. Problem number 4, find the length of the leg. If your answer is not an integer, leave it in simplest radical form. Now, if my directions on my assessment don't say that, you know that I will not let you leave a radical in the denominator, right? So you really need to get rid of that radical. All right, so what is my answer here? For those of you that are doing it in your head, awesome. Divide by square root of 2, I agree with you 100%. But dividing by square root of 2 would give us this, right? So if you said divide by square root of 2, I'd say, yeah, that is absolutely correct. 16 divided by square root of 2. That's right, but it's not in simple radical form because you have a radical in the denominator. That means it's not. So I'm going to multiply top and bottom by square root of 2. Square root of 2 times square root of 2 is 2. So I have 16 over square root of 2. Well, now I can simplify that down. So I'm left with 8 square root of 2. Boom. Pretty cool. Okay. All right. I know I'm talking real fast right now. I will slow down. I get excited when I'm doing math. Any questions up through number 4? Okay. Any questions? Okay, you guys okay? I mean, special triangles, they're one of those things that, you know, once you understand them, they really do help out a lot when you're trying to solve. Now, could you solve this another way? Sure. I mean, if I didn't know special triangles, I would know that this is x and this is x, right? Because I know they're both the same length. So I could do x squared plus x squared is equal to 16 squared. I could add that together. That gives me 2x squared is equal to, what is 16 squared? 16 squared would be, oops, my calculator's off. 16 squared would be 256. Okay, I could divide through by 2. So that would give me 128. So I'd end up with x squared is equal to 128. Then I could take the square root of both sides. Well, guess what? If you reduce the square root of 128 down, you're going to get 8 square root of 2. So you could have did it that way. We could have used sine, absolutely. Okay, so let's do it using sine. So if I wanted to use sine, I could say, okay, the sine of 45 degrees is equal to x over 16. Well, what is the sine of 45 degrees? My trusty calculator says that the sine of 45 degrees is 0.707. So that's 0.7071 is equal to x over 16. Now, what's the problem going to be there? The problem that you're going to have doing it that way is you're going to get a decimal, right? And as soon as I see a decimal, I'm going to say, you didn't do it the way I wanted you to do. Now, would your answer be correct? Sure, it would be correct, but it's not in radical form, okay? So there is a difference between, and that's why a lot of people, when they put decimals down on their assessment, I'm like, okay, they're not using special triangles, they're just using sine, cosine, tangent, which is cool. I mean, it is a method, but it's not the method I want you guys to use. All right, problem number 5. 30, 60, 90 now. So what are the two missing sides? What are my two missing sides here? $30 and $60. 30 and 60. I don't even see 30 and 60 up on that for an answer. How can it be 30 and 60? All right. Remember, I have the hypotenuse. Go from the hypotenuse to the short side. We divide by 2, right? It's just cut in half. Just cut in half. So 20 square root of 3 divide by 2. That gives me 10 square root of 3. That's my short side. To go from the short side to the long leg, we multiply by the square root of 3. So 10 square root of 3 times the square root of 3, which is 10 times 3, which is 30. So my short side is, let's see here. So it's not A, right? Because y is 10 square root of 3. So I'm going to go, this is 10 square root of 3, and this is 30 here. So I'm going to go with letter D. Now, it's kind of a tricky question, right? Because A has the same values, except one is X and one is Y. So you have to make sure you're real careful with that. All right. Number 6. Special triangle. This time they gave us the short leg. So the hypotenuse is just double it, right? So if I wanted to get to hypotenuse, I just multiply the short leg times 2. So that's 34. If I want to go to the long leg, I just take the short leg times the square root of 3. Wow, how easy is that? There's not even a whole lot of thinking in this problem. So that is where I want you guys to be. I want you guys to be to the point where you can just look at something, 30, 60, 90 degree triangle, 45, 45, 90 degree triangle, and just be able to look at and tell me what the missing sides are. D again. And it will take some people. I mean, some people have seen this already, but once you get to it, once you understand it, it really is cool. All right, problem number 7. This time it's not a special triangle, okay? And I can tell by the answers. All the answers are decimals, right? So what do we have to use on this one? We have to use trig, right? Sine, cosine, tangent. Which trig function am I going to have to use? I'm solving for x, because that's your first step. You have to figure out tangent is absolutely correct. Why is it tangent? Because I have, oops, I'm on the wrong slide here. I have 20 degrees here, so this is the opposite side. This is the adjacent side. Opposite and adjacent. Tangent of some angle measure is equal to the opposite side over the adjacent side. So the tangent of 20 degrees is equal to 9 over x. So now, I don't know what tangent of 20 degrees is, but I do have a calculator. Now, if you don't have a calculator, just go to decimals. Decimals can do this. So I end up with 0.3639. So 0.36397 is equal to 9 over x. And now, It just becomes solving. What I would do on a problem like this, if I had to solve it, I would cross multiply. 9 times 1 is 9. 0.36397 times x. And then my last step would be to divide both sides by 0.36397. So I end up with what? 9 divided by 0.36397, which is 24.7, 24.7. And that triangle definitely is not drawn to scale, right? 26.31. What did I end up? I ended up with 24.72. Now, it all depends on how much you round your tangent to. See how I took my tangent out 5 decimal places, 0.36393 or 0.36397. Now, if you just did 0.36, it's not sine though. Remember, it's tangent. This is not, darn it. This is a tangent function. So if you would have did 9 divided by tangent of 20, you would have gotten it correct. Okay. Yeah, and Desmos is fine. The only thing you have to worry about Desmos is just make sure it's in degree mode and not radian mode, because it makes a huge difference which mode you're in. Same thing with your calculator. All right. Problem number 8, it says write the tangent ratios for angle y and z. Okay, so this kind of basically goes back to last week. You can't set your normal calculator to degrees. There has to be a way to do it, because most calculators are degrees and radians. Most you can flip back and forth. So in this problem here, they're just asking us to write the tangent ratios for angle y and z. So if I did angle y here, it's going to be the sine of y is equal to 3 over square root of 34. Oh, it asked me to write the tangent ratios. I'm sorry. All right. So the tangent of y is equal to, so that would be 3 over 5. And if I did z, the tangent of z is equal to 5 over 3, because it's opposite over adjacent. So that's all they're asking for in that problem. Okay. Okay. All right. Problem number 9. It says write the ratios for the sine and cosine of A. Okay. So in order to solve a sine cosine problem, you have to know how to set up the proportions. So in this problem, I would do the sine of angle A, that's up here, opposite over hypotenuse, so that's 3 over 5. Cosine of angle A is adjacent over hypotenuse. And that is all they're asking for on that problem. Oh, you can't look away from your screen for 2 seconds? No way, JB. Can't do. All right. Problem number 10. All right. This problem is what the last problem on the assessment deals with. Okay. Now, I'm going to show you what I want you to do. Now, on the assessment this week, it says use the unit circle. I don't want you to use the unit circle. I want you to use special triangles. So the first thing I'm going to do is I'm going to change this to a degree measure. Okay. So that's what I want you to do on the assessment this week. I want you to change it to a degree measure. How do I do that? I just rewrite this. This would be 180 over pi. Reduce that down. So that's 60. So that's 600. Okay. So I have a 600. So basically, I'm asking you to find the sine of 600 degrees? Well, I need a reference angle. Remember, we did that last week. So 600, that goes all the way around one time, and then, so I just take 600 minus 360, so that's going to give me, what is that going to give me? Oops, what am I doing here? 40, is that 240? 240? Okay, so the sine of 600 is equal to the sine of 240 degrees. They're exactly the same thing. Now 240 degrees ends up right about here, doesn't it? So it's in the third quadrant. Is the sign positive or negative in the third quadrant? It's negative. So I can cross off this answer right away. This answer cannot be an answer, right? Can't be. I know it's negative in the third quadrant. Now, what angle is this? So I have, this is my reference angle. What is that reference angle? What is my reference angle in this problem? 40 degrees? Disagree with you. 60 degrees. Right, because if this is 180 here, if this is 180 all the way to here, and I'm going to 240, I'm going 60 degrees more. That's my reference angle. So this is a 60-degree angle here. That means this is 30, this is 90, okay? So now I have a special triangle here. I can let this side be anything. Well, when we're doing reference angles, our hypotenuse is always 1. So that means my short leg is 1/2. That means that this is the square root of 3/2. Okay. It asked me for the sine. Sine is opposite over hypotenuse. So I've got the square root of 3/2 over 1. I know it's negative. That is my answer. So what did I just use? I used over 50% of what we learned last week. Last week we learned how to change a radian measure to degree measure. Okay, that was my first step. I got it to 600 degrees. Then I used reference angles. So I went around 360. That was all the way to here. So now I have a reference angle here of 60 degrees. That was last week's work. And then I just used the 30, 60, 90 degree triangle. Always when we're doing, using the unit circle, okay, our hypotenuse is always 1. So now if this is a 30, 60, 90 degree triangle, my hypotenuse is 1, my short leg is 1/2, my long leg is square root of 3/2. Sine of 60 is opposite over hypotenuse. The last thing I had to do is think about, is it positive or negative? Since it's in the third quadrant, it is negative for sine. Sine is positive in the first two quadrants, negative in the third and fourth. So that type of problem uses everything that we learned last week and this week. Being able to change from degree to, from radian to degree, being able to write out a reference angle, and then using special triangles. Why were all the values on the special triangle divided by 2 from the original values? I'm not exactly sure what you're asking. It was 30, 60, 90 degree triangle because the reference angle was 60 degrees. I'm not 100% sure I understand the question. Now, if you're talking about a 30, 60, 90 degree triangle, the reason it was divided by 2 is because if it was an equilateral triangle, we cut it in half. So if you had the hypotenuse to get to the short side, you cut it in half. that just is, you know, because if you have a special triangle, let me see if I can get rid of this. You know, that goes back to what is an equilateral triangle. An equilateral triangle is a triangle that has all sides the same, all angles the same. But if you cut it in half, now you end up with, you know, if I just brought this triangle out, I end up with a 30, 60, 90 degree triangle. Well, if this is 10, like it was here, what would this length be now? Well, it's cut in half, so it's just 5. So if you go from the hypotenuse to the short leg, you cut in half. If you go from the short leg to the long leg, you multiply by the square root of 3. Those are just the way that it works for that. I hope I answered your question. I'm not 100% sure. Oh, we have one more. We have one more question on the practice. I didn't know we had 11. Awesome. Okay, so use the unit circle. No, I don't want you to use the unit circle. I want you to be able to do this without the unit circle. So first step, we want to come up with what degree measure this is. So I'm going to use the skills I learned last week. What is 60 times 16? I don't even know what that is. 60 times 16. So that is a 960 degree angle. All right. So I am looking for the cosine of 960 degrees. Well, guess what? That's going to go around the circle a couple times, right? If you go around twice, that's 720. So I'm just going to subtract 720 from here. Oh, it looks like the same angle measure as before, 240. Oh, that's going to make it nice because now I know that this is going to be 240 degrees. So my reference angle is 60 degrees. So the cosine of 960 is exactly the same thing as the cosine of 240, which is exactly the same thing as the cosine of 60. Now, is the cosine positive or negative in the third quadrant? Is it negative? It is negative in the third quadrant. Cosine is positive in the first quadrant, and then negative in the second and third, positive in the fourth. Okay, why do I know that? Okay, because remember, here's the cosine graph. Cosine graph looks like this. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So it's above the x-axis in the first quadrant. It's below the x-axis in the second and third. So that means it's negative down here, positive up here, positive up here. So first and fourth quadrant, it's positive. Cosine is negative in the second and third. So my answer is going to be negative. So I can cross off this answer. I can cross off this answer. Now, remember, the radius is always 1. So this is 1/2 square root of 3 over 2. Cosine of 60 is adjacent over hypotenuse. That's 1/2. So it's negative 1/2. So does somebody have a calculator on them? Can you put in the cosine of 960 degrees? And I hope you get negative 0.5. If you don't get negative 0.5, we did something absolutely incorrect. This is the kind of stuff that I want my calculus kids to know when they come into me, because this is the trig that is used in calc and in higher math classes. Okay. Yeah, negative 0.5 because your calculator is decimals. Whew. I think you guys are going to have a pretty easy time with this week's assessment. Not a lot of work. Number 4, you do have to show your work. Okay. I want to see your work on number 4. But other than that, you can just give me answers. All right. That is it for today. If there are any 45, 40, 90 triangles, or are they all, there'll be 45, 45, 90 degree triangles. Because if I gave you, let's say I asked you to find the sine of, let me clear this out. let me say, I want you to find the sine of, one second. Let me, I want to make sure I do this right. Okay, so if I asked you to find the sine of 225 degrees, okay, what would you do? You'd graph it out. That would be your first step. That would come out right about here, right? So 225 is 45 more. So that would be a 45-degree angle here, right? So this would be 1. This would be, what is that, square root of 2 over 2? Square root of 2 over 2. So the sine of 45 degrees should be the square root of 2 over 2. However, it should be negative, right? Because the sine is negative in the third quadrant. So they could, but they all have to be 45, you know, a combination of 45, 45, or 30, 60, 90. You couldn't have, like, I could not ask you to do this and say, okay, find the sine of 200 degrees. You couldn't do it because that would give you a reference angle of 20 degrees, which then you'd have to use sine, cosine, and tangent. So that wouldn't do it. Reference angles look complicated, but they really are not. Now remember, guys, we do have a help session on Wednesday. Last week, I think I only had one student come into the help session, which made me really sad. I mean, I got a lot of work done, but help sessions are 1 o'clock until 2 o'clock on Wednesday afternoons. All right, you guys have a great week. Get outside. It's supposed to warm up this week. Bye. Do not be a hermit. Get outside.